Hi, yes, it's vintage oscilloscope time because I love oscilloscopes, and in particular I love this one, the 54622D Agilent. Well, it was Hewlett-Packard back in the day before they changed their name to Agilent. Now they changed it again. Bloody Keysight technologies are ridiculous. Anyway, this is like a early 2000s vintage. I believe it came out in 2000 originally for the 54600 series. Now there is an earlier one to this, which is the 54645D, and they are significantly different looking. This one is more modern looking with the round style buttons and the rubber buttons. The other one, the 645D, very similar scope in terms of layout, architecture and specs and everything, with the mixed signal option, but it had the old style square HP buttons. This is before they, revamped the interface and went like this. And I love this scope. I use this extensively at companies I worked at back in the early 2000s, and I'd always specify it in. It was a nice compact scope like this, and really it was pretty much state of the art for its time, and it basically still holds up today. I mean, yeah, it's 100 megahertz bandwidth. This series actually went up to 500 megahertz, and it is only 200 meg samples per second, but that could double based on a single channel. It was 4 meg points of memory. I think an optional 8 meg points, which was absolutely huge back in its day to get a mixed signal scope with that sort of deep memory, and also, that's 4 meg per channel as well. You could actually interleave that and get 8 meg on a single channel. It was absolutely phenomenal back in this day, and it used the megazoom technology. I believe it was megazoom 2 at the time, and you're probably familiar with the modern Agilent 3000, 2000, 3000X series scopes. They use the megazoom 4 technology. This is the older megazoom technology, and this was marketed to the hilt back in the day, and it was extremely popular scope and still holds up today. I don't know anyone who's used this and does not like this scope. It is just absolutely brilliant. It's got sine X on X interpolation, so you could easily get 50 megahertz bandwidth out of that. 32 intensity grey scale screen. Yes, it is only a green screen, but it was true mixed signal, so you'd have the 16 channel logic analyzer as well. Fantastic. You could configure all that. You could trigger it. It had I2C triggering in here. Here it is. Where is it? More I2C triggering. It could do SPI and TV and pulse width triggering and pattern triggering and all sorts of weird and wonderful stuff. It was pretty much state of the art, and I loved the interface for this. It was so easy. Dedicated vertical controls, horizontal that just worked as you'd expect. Simple acquire menus, had real-time mode, or there it is. There's most of the time you operated the thing in real time, but maybe right up at the high end you might do the equivalent time sampling, stuff like that. Of course, it had full average in. What else have we got here? We've got, and it had vectors or dot mode. Now, the huge marketing claim for this thing was that it was 25 million vectors per second. Yes, not waveform updates per second, as you're more familiar with these days in marketing terms, but vectors per second. Whatever the hell that meant. I don't think anyone really knew back then what it actually meant. Display vectors, there it is, and it would basically, those vectors join in the dots, so to speak, the sine X on X interpolation. It could do 25 million of those per second, but I don't think Agilent ever sort of said or explained how that translates into real world waveform updating and dead time and all that sort of stuff. But oh man, it sounded impressive. 25 million vectors per second. Nobody else marketed their scopes like that. It was just fantastic. Anyway, I love this scope, and it's brilliant, and it's still quite usable today. So I highly recommend, if you can pick one up cheaply, put it on your eBay watch list and try and get one of these puppies. They are really good. Woven electronics, I love it. There you go, August 2000. I actually have the full 16 channel logic pros with this, with all the clips and everything. Fantastic. I got one of the original manuals, I think, and this one is in very good working condition. And even though it was grayscale, one of the beautiful things about this is that the resolution of the screen, which is still not matched by most scopes today. Even you pay $10,000-$20,000 for a scope, you don't get the resolution that's on this one. It's got 1,000 horizontal pixel resolution on its CRT. Absolutely phenomenal. 1,000 pixels. Most of them don't do that. Had exactly 255 vertical pixels for the waveform, so that you didn't, it wasn't sort of interpreting anything or adding pixels or anything like that. So beautiful, crisp, clear display when you zoomed out, and you get all that 4 or 8 meg of detail in there. Fantastic screen on this thing. It really was. Fan was always a little bit noisy in it, which was a bit annoying. You could save all your stuff to a 3.5-inch floppy disk, of course, and we'll check out the waveform intensity mode. And yes, as I said, 32 grayscale or green scale levels in there, so we'll actually compare it with a modern scope and see if it's any good. But I just love the way this thing operates. It was no fuss, well laid out, very simple, basic, nothing to get in the way, and it just worked well. It was a beautiful scope to use on a day-to-day basis. And yes, this thing had an Easter egg as well. To get to it, a bit convoluted. Press save recall, go into save, press new file, and then I love the entry mechanism on this. It just worked so smooth and so intuitively. Anyway, we go in there and we just go R-O-C-K. See how quickly I'm entering that? Rock on, dude. Rock on, dude. Creating bitmaps. Woohoo! Here we go. Fantastic. Look at this. Welcome to Rocks. Channel 1 knob rotates the ship. Fires a missile. Thrust moves the ship. Fantastic. Asteroids type game. Beautiful. Boom. I'm dead. Just look at the resolution they're able to get on this screen. It really is phenomenal. Top notch. And you've got to wonder why they were still using a CRT like this back in, well, 2000, when they designed and first sold this thing. Well, it was that horizontal resolution. You just couldn't get the LCD to give you that 1,000-point horizontal resolution that this thing has. Even, as I said, even today, you're struggling to find a scope that's got better than, that 800 by 600 type screen in it. This one's got 1,000 points. Awesome. And the other thing is, it boots up pretty quick for a digital scope. Check it out. Hear the floppy drive go, but bang, it's basically straight in. It took more time for the CRT to warm up than it did for the scope to boot. And of course, that flicker on the screen you can see is not actually the screen happening there. That's just the shutter speed of my camera. In this case, 25 frames per second, but I can increase that and it'll go away. Oops, sorry, I meant decrease, because if I increase it, I'm now at a shutter speed of 1/250th of a second, and look at that, shocking. And at my maximum shutter speed of 1/2000th of a second, look what we get. But of course the screen is just fine, there's nothing wrong with it visually, but on the camera, that's the effect you get. And here we have the old and the new side by side. Look at that. And well, this is 14, 15 years ago vintage, and the new 3000X series here. And the good thing about this, of course, is that it has a trigger output, so we can measure the waveform update speed based on the trigger speed. So I'm feeding in a 1 megahertz signal here from the function gen, and there it is on the screen, and we can read off the output frequency. Now, of course, this was advertised as 25 million vectors per second, which sounds fantastic. So what does that actually give us in terms of update speed? Well, not much by modern standards. Look at this, 520 hertz. That's bugger all. And actually, if I change that's at 5 nanoseconds per division, so that's the fastest time base. I increase it and it doesn't drop down until it's dropped down a fraction there. There we go, 10 microseconds, and it's starting to jump around there. But there we go. going down until we get to there, and we've got to adjust it, and we're down to, you know, that's at 500 microseconds per division. We're down to like 120 odd hertz. And of course, with our deep memory, which was a big feature in the day, 1 milliseconds per division, we can stop our sampling there and we can zoom right in on that, no problems whatsoever. Beautiful. That was a killer feature back in the day. Now here's an interesting aspect. We've got the trigger output here, and you can see we've got our trigger jitter in there. There's actually a fair amount of that, presumably because it's got, you know, it's got to do some interrupts and stuff like that. It's not, you know, like a fixed pulse output. So presumably that is the processing time that this scope takes to process the waveform after it actually captures it. And you can see if I change the time base, like all the way up to maximum 5 nanoseconds per division, as I said before, I have to go right down to, what is it, 500 microseconds per division before we see that pulse width change. And it was 1 microsecond before, now it's 585. So if we jump back, there it is, 1 microsecond. And you can actually see a bit of variability in this if we, let's have a look, move some of the controls. Look, see how it slows down if I move the horizontal time base like that. You can see that it's got to process that, and you can see the slower updating rate of that screen. So the waveforms per second is slower updating, so that we're seeing, well, effectively less jitter on there because it's not updating nearly as fast. So you'll see that if we go in here, here's our update. Well, let's go right in here like this, shall we? Let's go in right in there like that, and you can see that if we change that, boom, that control causes the horizontal, the update rate, sorry, to drastically slow down. There we go. And you can also see a difference. We're in real-time mode at the moment, and we're getting that pulse width there, the positive pulse width, about 1.4 microseconds or thereabouts. But if we switch real-time mode off here, bingo, look at that. It's extended all the way out to 17 microseconds, and then that changes with each time-based setting when we're in equivalent sampling mode. And you can see that's equivalent sampling and not actually real-time update in there. And just like the modern Agilent scopes, no, this one doesn't slow down when you do measurements. Like I add the measurements on there, and you can see there's no difference in the waveform update speed at all. Well, I don't know where the 500 and something hertz has gone. It's now 367, so I'm not sure what I've changed since then, but it makes no difference. We're getting 500 hertz before, weren't we? Anyway, I can turn on cursors, and I can move the cursors around, and look, it's not changing any of that user interaction on the screen, is not changing any of that update rate at all. So it's only when you do like the horizontal stuff, which is operating on the memory, like, you know, actually the display part of the acquisition system, that it changes. But anything to do with the cursors or measurements or anything like that, or other menus and operating the vertical time base and all that sort of vertical time base, vertical attenuator, then, you know, it doesn't do anything at all. You can go into utility menus and play around and all that sort of stuff. Acquire menu. You can even turn averaging on, for example. Doesn't affect the update rate at all. There it is, still 361 hertz or 361 waveforms per second. So it's like, this is like on par with like a Rigol DS1052E in terms of waveform updates per second these days. But back then, you know, oh, that marketing slogan, 25 million waveform vectors per second, that was a killer. And you can even do stuff like pulse width triggering, for example, and doesn't slow it down in the slightest. So it was, you know, I never had any issues actually using this thing. It was just so fast in operation, all the controls super responsive, and it just worked. It was a brilliant scope, still is. And how does the intensity graded display, as I said, 32 green or grayscale levels compared to the modern 3000 series? Well, they both look pretty shitty at 100%. I've got my 1 megahertz carrier frequency with the 1 kilohertz AM for 100% AM modulation here, but they're at 100% intensity. So if we wind that down, we start getting our true analog-like display there. Here we go. Oh, no, intensity controls over here. Look at that. I reckon I reckon it's superior. I like the old style one better. It really resembles an analog scope better than the 3000X series does. I mean, check it out. That's just, you know, that's like minimum now. I'm down at 0%. And look, you can see the higher intensity in the center there, and it's just a beautiful display. If you forget about the flicker, because this flicker doesn't happen in real life, we've got some trigger jitter there, by the way. It's not easy to trigger on this type of signal, but yeah, that is brilliant. I like it. Very analog-like display. I reckon better than the 3000X series. And we can, of course, freeze that and zoom in to our heart's content. Look at that. There we go. We can see our 1 megahertz carrier in there. And yeah, that's just beautiful. Absolutely. Thing of beauty and a joy forever. Look at that. Now let's see if we can see some runt pulses. I've got some runt pulses set up on this serial signal here, and they should be in there somewhere. And if we change the intensity, this is on the 3000X, you can start to see them in there. You see that? And of course, if we take our time base out, you can start seeing them in there. And of course, you can stop that and oh, there we go, we caught one. There we go. So there, just occasionally, there's these runt pulses in there, like there's a bus conflict or something like that. That's what it's simulating. Let's see what we get on the ancient 54622D. Okay, we have 100% intensity. Turn that intensity down. And yep, I can see the runt. Yeah, there we go. I should have had the exact same time base to make it fair, but you can start seeing the runt pulses in there. No problems at all. Look at that. It's all showing up. Yeah, not a problem. Look, bam. And so really, that works quite well. Just like, even though it hasn't got that super fast update in 1 million waveform updates per second, although I'm not sure at that time base it's not 1 million on the 3000X series, but you can certainly still see those pulses in there. No problems whatsoever. I like it. It's just as useful a troubleshooting tool as the 3000X is. And let's try that on a modern 5-year-old Rigol 1052E, and well, you can occasionally pick them up there, but the waveform update is much faster on the 54622D, that's for sure. You can just sort of see the runt pulses in there, and because this hasn't got an intensity graded display, it's not going to help you any in terms of turning that intensity down. I don't know, but that's in the center, so that's got nothing to do with it. No, in fact, that's just the is that just the graticule? No, I don't know, but anyway, not nearly as good as the 10-year-older 54622D. No contest. And it also has a fairly comprehensive set of internal self-tests as well, and built-in signals. There you go. It's generating various things and switching them internally. You can probably hear the relays clicking. Boom, boom, boom. There we go. And passed. It's very quick too. I like it. And it does have built-in math functions, not a huge amount, but you know, it does integrals and it does FFTs, and you know, everything's just fine. So about the only major thing it's lacking that you might get in a modern scope, say, is segmented memory, for example. And well, yeah, like there's other things, like there's no pushable buttons, for example, like centering the horizontal back. That'd be nice, things like that. You know, just small things, but as far as a modern functional scope goes, this one can pretty much hold its own against most scopes these days. Of course, the big feature back then, of course, was the mixed signal stuff, and you can do FFTs at the same time. So I've got FFTs, 16 digital channels plus the 2 analog. Well, there we go, the 2 analog channels as well, all superimposed. Shame it's not color in this respect, but you know, it's pretty good. You can change the size of the waveforms, of course. You can make them tiny like that, medium or big. You can actually set the threshold voltages to a user-defined level, so you know it's got a full level capability. There we go. I got it. Man, so many different scopes, so many ways to use them, and you can set the user-defined voltage. Pretty, you know, so it's a pretty usable mixed signal scope, and it's got, I believe, 400 meg samples per second on the digital channels and 1 meg per channel for the digitals, I believe. Don't quote me on that though. And as far as your internal I2C triggering, for example, goes, well, you can set the clock line to the analog channels or any of the digital channels, same with the data line, and then you can trigger off start, stop conditions and frames, and you know, it's all there. But I know what you're saying, Dave, I want to see inside it. Alright, here we go, let's take this sucker apart. By the way, I didn't show you the back. It's got a nice carry handle as well, and there we go. We've got a old school parallel port RS-232. There's an option interface for external modules. There's a trigger out and external trigger input. Nothing fancy. As I said, the fan was a bit loud. And just 2 screws on the back, and we're in. You called it, in like Flynn. Look at that. There we go, fairly neat and compact on the inside. I mean, look at that. There's, you know, plenty of space still left in there, of course, but as you'd expect, the main board is on the bottom, which we should be able to have a look at. Ta-da! There it is. We'll have a good look at that. And pretty standard, neck board and the CRT and all that sort of stuff. So nothing fancy going on there at all. But it is very neat and tidy and built very well. I'm not particularly keen on the big ribbon cable just going from the mains board over here by the looks of it. That's obviously carrying all the power out of it. So that's the power ribbon cable going down to the main motherboard on the bottom like that. Not too spectacular how they've routed that arrangement. And the front panel board, look at that, they've just got the ribbon cable going from the front panel there, so that's a bit untidy, but as you can see, nice big clunking power switch there going all the way, lever arm going all the way through to a real clunking power switch at the back. None of this standby power rubbish, and no, it's very neat and well designed. There's the neck board on the back there, that's fairly nice, held in place by Celastic there on the inside. And the CRT is certainly well braced inside this metal chassis here, so I really like that. That's really quite well mounted and tough and rugged. Oh, beautiful, because this sort of was a portable scope. As far as, you know, scopes went, this was designed to be a lightweight sort of portable scope you could take anywhere. That looks like a nicely designed and nicely laid out power supply board. In fact, it looks like it may have even been done by Agilent. I'm not entirely sure. It doesn't look like your usual shopped out job, but it is very well spaced. The main cap in here, Nippon Chemicon, no problems. The other ones over there are Rubicons, so top quality caps as you'd expect, and that's very neatly designed, well spaced out. It's not, you know, one of those compact designs that have thermal issues these days. And of course the fan is freestanding over here, easy to replace the fan if you want to put a silent one in there. And there's the front panel board, and one of the really good things about this scope is the quality feel of the knobs and the vernier, or the encoders on there. And these encoders, I'm not sure what brand they are, have no idea, but they just feel fantastic. A nice big, you know, solid, heavyweight sort of feel to them as you turn them. They actually require a fair bit of force. They just feel like they're going to last forever, and probably one of the best encoder knob feels I've ever encountered on a scope or any bit of gear. Just very nice. I love that sort of nice. It's hard to convey. You have to sort of play with it yourself, of course, but they just feel beautiful to spin. They really do. And there's the money shot. Let's take a look inside at specific chips. You can see the big 2 megazoom branded ASICs over here. Not just one, but looks like it's a dual chipset, maybe one per channel or something like that. Who knows? But yeah, that is neatly laid out, and easy access to the floppy drive here. If you want to modernize this, you could just replace it with one of those ones you can buy on eBay that duplicate the floppy interface, but they actually have a USB key on the front, and you can just stick a USB key instead, and it should be fully compatible. And there you have it. There's the main megazoom technology. No, they aren't 2 identical chips. They're actually 2 separate chips here. This is the MSO Mega. So this one they're using for the digital channels, almost certainly. And this one they're using for the analog channels. And yes, they do have slightly different part numbers on them. There you go, there's a closer shot of the two chips for those playing along at home. HP branded UPD 67823S1. Yeah, go figure. Is it a HP ASIC or is it just some rebranded regular, processor? It wouldn't be an ARM, of course, but some other, 32-bit processor or something just rebadged, most likely. Well, Googling that one, all I get for the UPD 67823 is that it's an NEC part now, Renesas, of course, and that it's an ASIC. Bingo, there it is. NEC gate array, 0.44 micron technology, 3.3 volt. Big ass 672 pin BGA, ultra high performance submicron gate, targeted for applications quite high speed, low power dissipation, blah blah blah, reasonable price, blah blah blah. It's got, here we go. Well, I'll link in the datasheet anyway. 11 base arrays with raw gates from 33K to 382K gates. Puzzle cell architecture. Ooh, mixed transistor sizes. Lovely. I like it. And it's got PCI interface blocks. Fantastic. PLLs. There you go. So very FPGA-like. And there it is, the UPD 67823. So 56,800 available gates, usable gates, only 39,000, and 200 I/O pads. Uses 3 metal layers in the technology. There you go. Interesting. So what are they doing inside that thing? Is it something to do with the, triggering system perhaps, or something like that? Maybe interface controllers for the megazoom ASICs, because it may be like the waveform update processing on the screen or something like that, although that's the megazoom. But yeah, it's interesting that it's located between the analog channels down here. So this is the front end. Here's the analog inputs, the digital inputs, physically located between them and the megazoom ASIC. So that's rather interesting. Looks like we might have another processor over here. So that's the one that probably controls the screen and stuff like that. We've got our flash memory over here and things like that. So it's not sort of the main, applications processor controlling this thing. I think that's probably going to be over here. So it's something to do with the megazoom acquisition and or triggering or something like that. If anyone knows, please let us know. And all of that's running from a main 200 megahertz clock oscillator. They're not mucking around there. And there you go for you Motorola 68,000 fans. There's the main application processor, 68C020 Classic. And there's the ROMs tucked under there. And there's what I'll call the analog megazoom ASIC, because it's dedicated to the analog channels. And then we've got our 2 sample memories here, separate ones per channel. And likewise for our digital megazoom ASIC, once again, as I mentioned before, separate memory for the digital channels, which is great. It doesn't share the analog channels, and there's quite a few memory chips surrounding that dedicated to all 16 channels. And I popped off the metal can on the front end, and ta-da! There it is. Looks like we've got some Lucent chips here. Let's take a close look at those. That's effectively one complete channel, basically there, duplicated above it for the other channel. There's another sort of relay up under there, which is under the plastic, which I can't really show you at the moment without disassembling the whole thing. There's not much there, trust me. I might be able to get the shot in there, because it's actually fairly dodgy how the BNCs are done in there. So I'll show you those in a second. We've got ourselves a Lucent, probably, I don't know, custom part, I don't know, we'll have to Google that, but I don't anticipate much luck there. But that's all we've got on the analog front panel, front end. Not much, of course, but hey, it's not huge. This is only 100 megahertz bandwidth front end, kiddie stuff. There it is, VB 1985. Well, good year, Back to the Future, awesome, but no, nothing, search doesn't turn up anything on that, so yeah, some sort of custom analog part. So there's the BNC on the front panel. That's probably the best shot I could get. It's securely mounted onto the front panel, no problems at all, of course, but then they're just running bare wire over to the main board there, and that other wire there isn't, I don't think that's ground, I think that's the ID for the ×10 probe. So there you go, that's about all she wrote for the Agilent 54622D mixed signal MSO scope. Fantastic scope for its day, incredibly popular, sold incredibly well. Everyone wanted one of these puppies, and still quite a usable scope today, so well worth putting. There's a whole bunch of part numbers, as I said, the newer model like this with the rounder button, there's the older style with the squarer buttons, slightly lower spec, but still very usable mixed signal scope today. If you can pick one up at a decent price, so well worth putting on your eBay watch list, that's for sure. So anyway, I hope you enjoyed that look at this 14, 15-year-old scope. And if you liked it, please give it a big thumbs up, of course. And if you want to discuss it, EEVblog forum is the place to do it. That is links down below. And as always, there will be high-res teardown photos on EEVblog.com. That's linked in down below as well. Catch you next time.